Good morning, class. Today is April 15th, and we're going to be working in Chapter 12. And you're going to find this probably a little bit more enjoyable than some of our other topics that we've been dealing with. And perhaps that some of you did a few of these things when you were in algebra class. And we're going to look at, in 12.1, we're going to look at what is called the product rule. The product rule tells us how we can multiply terms that have exponents. The rule says a to the m times a to the n. All we have to do is to add the exponents. Example would be y cubed times y to the 7 is y to the 3 plus 7, or y to the 10. Another example, z cubed times z to the 10 times z to the 4. I'm merely going to add all the exponents, 3 plus 10 plus 4, and I get z to the 17. Now notice these bases were variables, but our base can also be a constant. 4 squared times 4 to the 5. I do not ever change the base. I'm going to add the exponents, and I'm going to get 4 to the 7. Let's look on page 841 at number 3 there. And 841, look at 3e, and I want you to notice the difference here between 3e, which says 4 squared times 3 to the 5. And I want you to compare this question with the 3 examples I just gave you. Notice over here I had all the same bases, all y's. Here I had all z's, and here I had all 4's. Notice in the rule, the base must be the same. But here we have base 4, and then we have base 3. There is no way we can multiply these. We cannot simplify the exponents at all. The only thing we could do is say, okay, 4 squared is 16, then figure out what 3 to the 5 is and multiply it, but we cannot do it in that form right there. Looking at F, we have 6 to the 4 plus 6 squared. And notice how this is different as well. This is not multiplied. We are adding these here. We have no way of adding terms that have unlike exponents. So no way to get an answer there or here. This is what our product rule refers to. I have a little more slack in between my explanations here because I had to change rooms, folks, and this room isn't as comfortable here. So let's look. Page 842, we're looking at number 4b. And here we have, what makes this different? 3p to the 5 times 9p to the 4. What makes this problem different is that we have coefficients. But not to worry. We multiply the coefficients together. We can multiply the terms that have exponents on the p here. So my coefficient product is 27. I stick with my rule. 5 plus 4 is 9. And there is my answer. And let's look at C, 4c minus 7p to the 5 times 3p to the 8. I'm going to repeat what I just did. I'm going to multiply the coefficients. The only difference here is that my one coefficient is negative. And then we have p to the 5, and we have p to the 8. So remember, when you're multiplying unlike terms, you get a negative. So we have minus 21. I'm going to add the exponents, and I get p to the 13th power. Looking on down, we're now going to look at the power rule. The power rule. And the power rule is exactly what it says. We're going to take a quantity that has an exponent, and we're going to take it to its own exponent. So the power rule, we multiply the exponents. A to the m, all raised to the n power, and we get a to the mn. Example, y cubed all to the 5th power. 3 times 5 is 15, and my answer is y to the 15. Look at b to the 6th, all raised to the 4 power. I'm going to multiply 4 times 6, and I get b to the 24. Likewise, with the power rule, we can have coefficients as well. 2ab, the quantity cubed, what this means is we're actually distributing this exponent of 3 over everything inside. So that would be 2 cubed times a cubed times b cubed. You can't forget any piece of that. So 2 cubed is 8, a cubed, b cubed. What if you have a negative in there? Minus 4r cubed. The whole thing is squared. So when we do this, the base here is negative 4. We're going to square it. R cubed, the quantity squared. So we have a negative to an even power. That's going to be positive. 16. 2 times 3 is 6. Whoops. I see that I'm in this new room here, and so I have to pay attention to this screen as well. And I have to pay attention to this mouse. Otherwise, I'm going to get cut out. So now let's look at this. We have inside our parenthesis, we have a quotient. And I see, okay, you can't see that. There it is now. I have to be careful here. So we have a quotient to the exponent m, and remember we're going to distribute that m over the numerator, and we're going to distribute it over the denominator. So we get a to the m over b to the m. The only stipulation is that the denominator cannot equal 0. Example, 4/3 the quantity squared. That means 4 squared over 3 squared, and you're going to get 16 over 9. Let's look on page 844, and we will look at C. C is P over Q, and that is the quantity squared. You're going to distribute the 2 over the P, so that will be P squared, and the denominator will be Q squared. Looking at the D, R over T, the quantity cubed, you're going to distribute the 3 over the numerator and the denominator, and we're going to get R cubed over T cubed. Okay? This is a little bit easier. Excuse me. Have a good day.
You too. Good night.
Okay. Okay, class. Fortunately, we get to see somebody now and then here at school, but not very often. So I have 1 over, I'm here alone a lot. So we have 1 over x to the 10. I'm going to distribute that 10. I get 1 to the 10 over x to the 10. So I have 1 over x to the 10. So none of these was what I would put in the category of being very, very difficult at all. We're going to have ones that are more difficult than that. So let me just recap. You want to have these rules written down. Maybe you write them down on a 3x5 card. I don't know how you might do it, but you want to write them down. So remember, the product rule says a to the m times a to the n is a to the m plus n. The power rule has a few subscripts here. So we're going to have a to the m all to the n power, a power to a power I multiply. If inside we have a product, I have to distribute that m over, and I get a to the m, b to the m. Inside could also be a quotient. I still am distributing that over, and I get a to the m over b to the m. And no matter what math we're in, no matter what our topic is, if we have a denominator that's a variable, the stipulation is always the denominator cannot equal 0. Look at page 845, and we'll look at 8b. 8b. So this would be a little bit more interesting. 5k cubed over 3, the quantity squared. So we have to distribute this 2 over, and that's going to give me 5 squared. I'm going to distribute it. I have k cubed, the quantity squared, and I'm going to distribute it, and I get 3 squared. So I have 25. 2 times 3 is 6, and in the denominator 9. Am I done? Yes, because 25 over 9 does not reduce. So this is a little more interesting. The other ones were our warm-up questions. Looking at this, we have, it's minus 3x. Let me see where I am here. Xy squared, the quantity cubed, times x squared y, the quantity to the 4th power. So this is pretty involved, this one here. So let's do it slowly. This means minus 3 cubed, x cubed, y squared cubed. Distributing, this means x squared to the 4th, y to the 4th. So let's go slowly. A negative number to an odd exponent is going to be negative. 3 cubed is 27. X cubed stays the same. 3 times 2 is 6. 4 times 2 is 8. And we now have this. So oftentimes I put like terms next to each other. And then I kind of gently cross it off to make sure I taking care of it. And then I have x to the 8. And then I have y to the 6 and y to the 4. Okay? So now I can see what I'm doing. My base is x. 3 plus 8 is 11. My base is y. 6 plus 4 is 10. So this was pretty involved. We had power to a power, we had a coefficient, power to a power, and then we had to multiply. So it took everything we learned and it put it into one question there. Turning your page, look at, well, let's see, no, 9 is at the bottom. 9. And let's look at A and B. So 9A says, find an expression that represents the area of the figure. So I was looking to see if it said area or if it said perimeter, but it says area. So this is a fair question because you need to know the formula for area of a rectangle. And my length is 8x to the 4, and my width is 4x squared. So it doesn't give us units, it just says appropriate units. So I have a positive times a positive, it's plus. 8 times 4 is 32, and 4 plus 2 is 6. That is the area. And then we're looking at a triangle. The base is 10x to the 6, and my height is 5x to the 4. So on this one, I'd have to give you the formula, but I bet a lot of you know the area of a triangle is equal to 1/2 the base times the height. I'm guessing a lot of you do. So my base is 10x to the 6th, and my height is 5x to the 4. So 2 goes into 10 5 times, and my area is 5x to the 6 times 5x to the 4, 25x to the 10. So these, I'm only choosing problems, everybody, that is in our world, things that are at our level. So the formula I'd have to give you, but this one, the area of a rectangle, is one you need to know. Okay, so you might be writing some kind of little formula sheet out. Okay. Now, we're on page 846, and we're going to look at some problems here. And let's look at number 20. I'm going to look at 22. I'm going to look at 34 and 38. I'm writing these down just because this room is not easy to work in here. So number 20, we have minus 9 squared. 22, I have the opposite of 9 squared. Number 34, I have n to the 5, n to the 6, n to the 9. And number 38, I have 3 to the 8 plus 3 to the 9. Okay? So I encourage you to have your book open as we do these. Notice we have parentheses here. So my base, the whole base is minus 9. That means minus 9 times minus 9. 2 negatives is a positive, and I get positive 81. Now compare this problem with this one. No parenthesis. This minus sign says opposite. My base here is positive 9. The base is positive 9. It is not minus. So I put down opposite, and it means 9 times 9 minus 81. Usually these are on a standardized exam. Okay? Usually they show up because it's important to know what's being said here. This is just normal. 5 plus 6 plus 9, 11 plus 9 is n to the 20. Look here. I have the same base. I have a 3 and a 3, but we have no way of adding numbers with exponents. We can multiply them, we can divide them. We cannot add them like that. Looking on down, I'm looking at 46 and 54 and 60. This is the only way it's working for me here. And this is y to the 6 to the 5. And 54 is 9pq all to the 6th power. And number 60 is 1/3 the quantity cubed. So none of these is a stretch for us. They're all things that you would know how to do. So a power to a power I multiply, and I get y equal 30. I'm going to distribute this across, and I get 9 to the 6, p to the 6, q to the 6. Now, if this coefficient had been a small number that we could figure out, we would do that on our own. But we really don't need to know what 9 to the 6 is, and your author just leaves it that way. He just leaves it written this way. This is the book answer. Remember, we have to distribute the 3 in the numerator and the 3 in the denominator. 1 to any power is 1. 3 cubed is 27. How are you doing there? How's it going for everybody? Perhaps when you watch these videos, you can set up a table and chairs. You can have your book open. You can write in your book, write in your notes, a good way to follow. Okay? So let's look now at 64, 72, and 78, and 98. And let me see what's going on here. So 64 is minus 5, m to the 4, p squared, and the quantity is cubed. Okay? So remember, we have to distribute this across every single factor. And we have minus 5, the quantity cubed, m to the 4, the quantity cubed, p squared, the quantity cubed. We have a negative number to an odd exponent. That's going to give me minus 125. 3 times 4 is 12. 3 times 2 is 6. You probably know what minus 5 cubed is. Some of these numbers we do know. So you could know that. Looking at 72 in parentheses, you're going to have 6y to the 5 power, and then you're going to have 6y to the 8 power. So this one is calling on you to analyze it a little bit. Remember, the bases have to be like in order to do this. So I have a 6y here and a 6y here, so my bases are like, and all I have to do now is never change the base, keep it as 6y. I'm going to add the exponents, and I get 6y to the 13. I'm not quite done. I have a power to a power, and I get 6 to the 13 y to the 13. So we're just going to leave that because 6 to the 13 would be a very large number, and the author just has that for a book answer. Looking at number 78, we have y to the 4 all to the 5, and then we have y cubed to the 5. So I'm looking here, I have a power to a power, that gives me y to the 20th. I have a power to a power, I have y to the 15. So now I'm doing the product rule, and I get y to the 35. Okay? Looking on down at 98, we have our shoebox here. So we know how to find, what does it say? We want to find the volume, and we are given 5x cubed y. We are given 4x squared y to the 4, and we're given 9xy cubed. So let me check to make sure I have these copied correctly. I do. And remember, I will give you the volume. Volume equals length times width times height. So my volume is going to be whatever you choose to be your length here. So I'm going to have 5x cubed y. My width is 9xy cubed, and my height is 4x squared y to the 4. So this would be given. Some of you know it. I'm going to take care of my coefficients. I have 5 times 9 is 45, and then I have a 4 here. Okay? I now have x cubed. Here I have an x to the 1, and here I have an x squared. Then I'm going to have a y cubed, and a y to the 4. So 45 times 4 is 20, carry 2, 180. Don't forget that x has a 1 exponent. 3 plus 1 is 4, plus 2 is 6. On my y, 1 plus 3 is 4, plus 4 is 8. And I have this for my volume. So it's doing it as a good, and also we don't have any units here. It just says, nope, they don't give us any units. So this would be our final answer, but it would be units cubed. Whatever they gave us, it would be units cubed. Okay? So take your time. I would definitely show this step here. I wouldn't try to do everything in my head, and that's what you get. That would be a fair question. It looks complicated, but it's fair. Okay, we did 12.1. I need to move this mouse so I don't get shut out. There's so much to remember, so that everything works out correctly. Now, in 12.2, you are required to do only positive exponents. So that is what the college requires, is we only have to work with the positive exponents. Let me see if I can adjust this a bit. Okay. Only positive exponents. So there's an awfully lot of problems we're going to be skipping because most of them are negative. But here's a big idea here. this is a big idea, and that is you need to know a to the 0 is 1. So all of us know that. A to the 0 is 1. Example, 3 to the 0 is 1. Minus 4 in parentheses is 1. XY in parentheses to the 0 is 1. So that is a big idea there, is to know that anything to the 0 power is 1. We'll be skipping a ton of these, so because they're all negative exponents. But let's pull out the ones that that we can do. I'm looking on page 855, and we have 5 to the 0. So anything to the 0 power is 1. 14 minus 10 to the 0 power. So my base is minus 10. Anything to the 0 power is 1. Okay, look at 16. I have a star on it. 16 is minus 5 to the 0. We talked about this. My base, the base is 5. There's no parenthesis, so this is the word opposite. So step 1, I'm covering up the minus sign. 5 to the 0 is 1. And then I bring over the minus sign, and I get negative 1 there. Big idea. You need to redo that so that you understand all the differences with parentheses and minus signs. 18, we have minus 8 to the 0, minus 8 to the 0. Okay? So minus, no matter what is in here for the base, that's a 1. Bring down your sign of subtraction. 8 to the 0 is 1, and my answer is 0. 20. 0 to the 5 over 5 to the 0. Wow. What's going on here? Well, we know that 0 to any exponent is 0. 5 to the 0 is 1. Can we have 0 in the numerator? Absolutely. And we get a 0 there. Okay, hold on here. Let's look at 32 and 34. See what's going on. 32 minus 5t to the 0, and 34 is 8 to the 0 plus 6 to the 0. We really want you to know what anything to the 0 power is. Makes no difference what the base is. I'm going to get a 1. Here, 8 to the 0 is 1. Bring down your sign of addition. 6 to the 0 is 1. And my sum is equal to 2. So all of those are required. None of them had negative exponents in them. So now we're going to look at the quotient rule. So we would add these to our list of rules. And that tells us that to divide numbers with exponents, we're going to subtract. Example, a to the 12 over a to the 4 equals a to the 12 minus 4, or a to the 8. So we subtract, well, you're going to go with this a little bit differently once you're working with negative exponents, because we always want a positive exponent, but since we're doing only positive, it's going to be the numerator exponent minus the denominator exponent. We always want to keep that positive. Another example, 5 to the 7 over 5 cubed. Subtract the exponents and we get 5 to the 4. To divide numbers with exponents, you subtract. Looking at number 60, see all the rest of those problems were all negative exponents. So I'm pulling out ones with positive. 3 to the 8, y to the 5, over 3 to the 10, and y squared. Okay? So I see that 10 is bigger than 8. So I'm going to subtract 8 from 10. I want to keep the exponent positive. I see that 5 is larger than 2. So I'm going to subtract the 2 from the 5, and that gives me y cubed over 3 squared. Okay, I know what 3 squared is. I know it equals 9. So that would be a fair question. 15, m squared over 3m. Okay? To divide numbers with exponents, we subtract, but we know how to divide 15 over 3, and then we're going to have 2 minus 1. So 5m to the 1. And then number 70, 5 cubed, the quantity squared, over 5 squared. So you're not going to be slashing anything, people. We have to do the computation first before we actually do the division. So step number 1, 3 times 2 is 6. And now I have 5 to the 6 over 5 squared. To divide numbers with exponents, you're going to subtract, and you get 5 to the 4. Okay? So in 12-2, you're not going to have much homework assigned. We have to stick to only the problems that have positive exponents. But you do have to know any number to a 0 power is equal to 1. Okay? I'm just going to get up and walk around the room for a second in order to turn on my light. So that will just take me 2 seconds, because it's no fun being a raccoon here and working in the dark. Okay, folks, I'm back. This is really a challenge. See, when you're in the classroom, you're moving and everything, and the lights don't go out on us. But I have this empty classroom, and the college has it set up that when there's no movement in the classroom, the lights go out, and it saves them a lot of electricity money. 12-3 is what we call scientific notation. And you're not going to use it in math very often, but it's something you would use in science. You would use it in biology and chemistry and physics and so forth. So our job in the math department is to show you how to do scientific notation so that you can do it when you're in your science classes. And once again, we're going to deal with positive exponents only. So that leaves out a lot of these problems. And what do we use scientific notation for? We use it to take either an extremely large number and make it small and more manageable, or an extremely large number, 3, 4, 5, 6, 7, 0, 0, 0, 0, 0, 0, a number like this, and we can make it more manageable, or an extremely small number, something like this, like that, and make it more manageable. I mean, we just can't work like that in science. We have to have it in a different notation. So step 1, we're going to place a caret to the right of the first non-zero digit. Where the decimal point will be placed. Okay, that's step 1. And then step 2, we're going to count the number of digits from the decimal point to the caret. This number is absolute value of the exponent on 10. So that's meaningless to you, giving you those steps. But let me give you an example here. If we had a number like this, let me pick one out of the book here. I'm looking at something on page 861, and let's look at number 6 and see what they give us there. Number 6, we have 34,000, like that, and the question said, let us write this in scientific notation. Step 1, place the caret to the right of the first non-zero digit. So my first non-zero digit is 3. I placed a caret to the right, so that was step 1. And so now that's going to be where I'm going to put the decimal point, where the decimal point will be placed. And then it says count the number of digits from the decimal point to the caret. So I'm going to have 1, 2, 3, 4. And that is the exponent on the 10. Okay? Remember when we moved decimals to the right and the left, we're working with powers of 10. Okay? So this is scientific notation here. Your number here will always be between 1 and 99 something. No, not 99. 1 and 9. Okay? So it will be less than 10. It can't be 2 digits. It has to be 1 digit. Okay? So that is an example of scientific notation. We put the caret here, and then we count the decimal points. 1, 2, 3, 4, and the exponent on 10 is 4. Let's look at number 10. Number 10 is this is let me do something else. That one's a little bit harder. let me just make one up right now. Let's say that we have 5, 6, 7, 0, 0, 0, 0, 0, 0, 0, 0. So 3, 3, 3, okay? And that's too big to manage when we're working in math or science. So I'm going to put my decimal, my caret there. I have 5. There's my caret, 0.67. Well, I should have, this is where we put the caret, so that's replaced by a decimal point. So we have 5, 6, 7 times 10. Now I'm going to count from here over to the caret. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it gives us 5.67 to the 10. Okay? This number always has to be between 1 and less than the number 10. So 9 something. Looking at, let's see, that was not number 10. That was my example. So now let's look at number 10. He's throwing this in to be tricky. And his question is this. He says, is this in scientific notation? Is this scientific notation? The answer is no, because 0.9 is not a number between 1 and 10. So it's not in scientific notation. To change it, and this is a little bit trickier at the very beginning of this lecture, is that I'm going to move the decimal point one place like this. Do you agree when I moved it like that, I multiplied by 10? So if I multiplied by 10, I have to divide by 10 here, which would subtract 1 from 3, and I would get 10 squared. I can check this out. 9 times 10 squared is 9 times 100, which gives me 900. And 0.9 times 10 cubed is 0.9 times 1,000, which gives me 900 as well. Okay? This, you have to be used to working with scientific notation to recognize that that is not scientific notation. In other words, you have to start training your eyes to pick some things up like that. So let's look. I am on, I'm actually going back a little bit to number 2. I'm going back to page 859. Let's do this here. Page 859. And let's look at 2a. 2a says 1.2 times 10 to the 4. And the question says, move the decimal point how many places? I already have the caret in the right position. And so I'm not going to move it. Oh, I see. Write each number in standard notation. Okay. Write in standard form. That means we have to actually multiply it out and get a number. So we're going to have this. This tells me to move it 4 places to the right. Okay, so I have this. So I have 1.2. I have to move it 1, 2, 3, 4. That tells me I'm going to add on 3 zeros. I went from here to here as 1, 2, 3, 4, and I get 12,000. Let's look at B. 8.7 times 10 to the 5th. This tells me I have to move my decimal 5 places. to the right. Okay? So 1, 2, 3, 4, 5. I now have 807. 5 places to the right. 1, 2, 3, 4, 5. 870,000. That is correct. And then number C, I have 7.004 times 10 to the 0. Well, I don't even have to think about this because 10 to the 0 equals 1. So I have 7.004 times 1 is 7.004. Okay? So we're going to throw in that 0 exponent every so often. So going back now to the problem set, we did 8 and 10. Let's go down to number 14. Number 14 is 9994, 9994, and then I have 6 zeros. 1, 2, 3, 4, 5, 6. And the question says, write this in scientific notation. So I'm going to put my caret here because I want a number. Actually, it's a number between 1 and 10, isn't it? I said 1 and 9 because I didn't want you to put a 10 there. So let me change that. It's not 1 and 9 really. It's really 1 and 10, but we just don't get to the number 10. Okay? So that was too fast. I saw what happened on the video there. It was like speed dial. So just go back to your notes and change that to a 10. And remember, I'm going to scan in all these notes as well, and they will be available on D2L, is all the notes. But it's good to see both the video and the notes. So I did my caret. That's where the decimal point goes. And now I count 3, 6, 9. Now make sure you put the 10 here. I have students that put the 9 on this number here. But scientific notation is the number times 10 to an exponent. So you must have the base 10 there. That's what we need to have. Looking then at, that was 14, we're looking now at 16. 1,78,330. So I'm going to put my caret here, and that gives me 7.833 times. I need the base 10, and then I count from here. 1, 2, 3, 4. And I have 10 to the 4. My lights are out again, so I'm going to have to bring a flashlight or something. 24. We want to go in the other direction. 8.766 times 10, and the exponent on the 10 is a 9. A 9. So this tells me I have to move this 9 places to the right. Okay? So I have 8, 7, 6, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have here, here, and here. That is my answer. So remember, this is scientific notation, and this is standard form. 38. On 38, we have 3 times 10 to the 7, parenthesis, and then we have 3 times 10 cubed. Now, the only reason we can multiply these is our base here is 10. So what this means is 3 times 3 times 10 to the 7 times 10 cubed. So 3 times 3 is 9 times 10. You must have this base 10. I add the exponents and I get a 10. Okay? So we have that scientific notation, and then he asks us to put it in standard notation as well. So let's go to standard. This tells me I need to move the decimal 10 places to the right. Okay, so I have a 9. My decimal point is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 zeros, 3 zeros, 3 zeros, and I have a 90 with a comma. That is exactly correct there. And let's look at 40. On 40, I have 8 times 10 to the 5, and I'm going to multiply that 2 times 10 cubed. Now, once again, the reason we can do that is because my bases are like. So I have 8 times 2 times 10 to the 5 times 10 cubed. 16 times 10 to the 8th. Okay? So that's not scientific notation. That isn't. This 16 is not between 1 and 10. So I have to change 16 to 1.6. So I moved my decimal place 1 point. I actually divided by 10. So if I divide by 10 to balance it, I have to multiply that by 10 and add 1. So I move this 1 place to the left. I have to add 1 in order to balance that out. So now we're going to get that's exactly right, 1.6 times 10 to the 9. And then our answer is, this tells me to move 9 places to the right. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 places. So I'm going to probably ask you one problem where you have to recognize that this is not standard notation for scientific notation, that you had to go to 1.6 there. I probably will ask you one of those. Let's see what 52 is, if we need that or not. Yes, we do. 15 times 10 to the 4 over 3 times 10 cubed. So this is my multiplier, just numbers. So 15 divided by 3 is 5. To divide numbers with exponents, I subtract, and I get 15 times 10, I get 5 times 10 to the 1. Okay? So this is scientific notation because I have base 10 here, and it's just 10 to the 1. And does he ask us to multiply that out? Sure he does. So this would be standard form, and then that would be scientific form there. And now 64 is a little bit harder, is that we have 1.81 over 3.21, and this is 10 to the 13, and this is 10 to the 8. So when that is actually it's a word problem. I just can't see it. It says that Congress raised the debt limit to 1.8 times 10 to the 13. So this is the debt limit. So it's money to the nearest dollar. How much was this for every man, woman, and child, given we have 321 million in the population? So 321 million, hundreds, thousands, millions. So to go to scientific notation, I put my caret here. To get my exponent, 3, 4, 5, 6, 7, 8. And that's how I got that denominator. So we're dividing dollars by people here to find out how much each person got. And so you have to divide 3.21 into 1.81. And when you do that, you have to move this 2 places and 2 places, and you're going to get 0.563862. Okay? You're going to get that. Obviously, you're doing it with your calculator. So I now have this times 10. 13 minus 8 is 5. Am I in scientific notation? No. I need a number between 1 and 10. So I'm going to move it here, 5.63862. And what do I have to do to my 10? Since I increase this, I have to decrease this to balance it. And he evidently wanted us to round off here. So I have 5.6386 times 10 to the 4. And then the question is, we want actual. We didn't even have to go that, yes. So we want the actual, so this tells me to move decimal 4 places, and I'm going to move it 4 places, and I get 56386 dollars per person. Okay? That's what it asks for. It says what was the total number? Wait a second here. How much was this for every man, woman, child in the country? 56,386. Okay? So, excuse me 1 second again. I'm going to go turn the lights on and take a drink of water. There's no pause on this thing, so I can't pause it, but it will just take 1 second to do both of those, and then we'll be back to do 12.4 here. Okay, so it gave you a couple second break, and it gave me, I was able to walk and get the lights on here. Now, I would say a lot of you may not have ever done scientific notation, and the use in math is very minimal. Once again, it's our job in math to teach it so that you can be successful in your science classes, biology, chemistry, and physics there. I don't know what you'll be taking. So 12.4, add and subtract polynomials. Okay? So if we know how to add and subtract, and we know how to work with signed numbers, we're going to be okay here. It's not going to be that hard. And also you have to recognize like terms. So on page 865, we're discussing terms and numerical coefficients. Oh, there's a chart there that I wanted you to just kind of look at. So this is what I wanted you to see here, is that we have this chart, and if we have a constant term 8, the numerical coefficient is 8. If we have minus 7y, the numerical coefficient is minus 7. My coefficient is 34. My coefficient is minus 26. Now, minus k really means minus 1k, so we have minus 1, plus 1, 3/8, and 1/3. So numerical coefficient is exactly what the word says. It is a number we're looking at. So let's go forward then. Is what we're going to do is we're going to be adding like terms, which we have done already. We already did this. You know how to recognize like terms, and on page 866 we're going to do 2a through f. So let's look. I don't know if I'm going to do all of them. We already did quite a few of these problems here like this. And we have a is 5x to the 4, and it wants us to add 7x to the 4. What makes these like is the x to the 4, and we get 12x to the 4. For b, 9p cubed plus 3p cubed minus 2p cubed. These are all like, so I can add these. I get 12p cubed minus 2. 12 minus 2 is 10p cubed. Let's look at C. C says r squared plus 3r plus 5r. 5r squared. So we have to recognize what is like. So the coefficient is 1. 1 plus 5 is 6. This stands alone. We cannot combine the 3r. D, x plus 1/2 x. We know this coefficient is a 1. 1 plus a half is 1.5 x. We would not write it that way, mixed number. We would change it to 3/2 x. And that became 2 plus 1 is 3 over 2. E, 8t plus 6w, we cannot combine. Why? They are unlike terms. and f, 3x to the 4 minus 3x squared. These are unlike. We cannot combine unlike terms. Okay? I think that you're pretty good at recognizing what's like and unlike. These are not the same. These are not the same letters. We can't go forward with them at all. Now, a little bit of just vocabulary here is that we're looking at the degree of a term. The degree of a term is the sum of the exponents on the variables. Okay, so if we have one term and the question says to find the degree on it, let me see if they have one like that. Verify the coefficient. I don't even know if they have that question in the book here. Find the coefficient of each term in the expression, number of terms. Okay. So let's I don't even know. I don't see it in the problem set here that they even asked it. So I don't exactly know why they stated that, but they did. The degree of a polynomial this is the sum of the exponents on the variables, so the degree of a term. So I feel I need to give you an example. I don't see anything in the book there. So if we had a squared bc cubed, it says the sum of the exponents on the variables. Even though these are different, we would have 2 plus 1 plus 3 is 6. Okay? So how often in life do we even have to do that particular question? Almost never. I mean, I can't even imagine when we do. But we do talk about the degree of a polynomial once in a while, especially in word problems. Is the greatest degree of any non-zero term of the polynomial. Okay? We have a lot. Poly means many. That means many terms. But we have special ones. We have a monomial, which is one term. Example, just what I had up there, a squared bc cubed, one term. There's no add or subtract signs. A binomial, which is two terms. Example would be x squared minus 3x. A trinomial, well, you know what tri means. Trinomial means three terms. So that would be y cubed minus y squared plus 10y. One term, two terms, three terms. Let's look at these problems. We're looking at page 867, and we're looking at problem number 4, and we're looking at 4a, and it says 3x squared plus 2x minus 4. For each polynomial, first simplify it. Okay, there's nothing for us to simplify. Then give the degree and tell whether the simplified polynomial is a monomial, a binomial, or a trinomial. So looking at 4a, it cannot be simplified because my exponents are unlike. And we want to know what degree it is. It is degree 2 because that's the highest power appearing. How many terms do we have? We have 3, so it is a trinomial. Okay? Looking at C, x to the 8th minus x to the 7 plus 2x to the 8. I look to see, can I simplify it? These two are like, so 1 plus 2 is 3. I ended up, so this is the degree 8. I have 2 terms, so it is a binomial. And number D, 6ab minus 7ab and plus 3ab. These are all like. I can combine them. 6 plus 3 is 9, minus 7 is 2ab. And we're looking at that. The degree is 2. How did I get that? 1 plus 1. Degree equals 2. That's the only problem I see like that. Since it's exactly one term, it's a monomial. Okay? A monomial. Let's see, I need to push this up. There's something crazy about this, the way it's aimed. Okay, I need to make it more like this, maybe. Okay, let's see how this works here. So now, I don't think anything here has been that hard. Maybe the terminology is a little bit different for you, but nothing is that hard. So looking at 5b, we're going to have evaluate. Find the value of 2x cubed plus 8x minus 6 when x equals 4, 5b. So we know how to substitute in. We've done that before, but now we have exponents. So I have to put the 4 in every time an x appears, and I have 4 cubed plus 8 times 4 minus 6. So I need to know what 4 cubed is. Well, 4 squared is 16, and 4 cubed is 64. 8 times 4 is 32 minus 6. This is going to give me 128 plus 32 minus 6 is 26. So 128 plus 26, 14, carry 1, 154. That is the value. So we have evaluated before, but ours did not necessarily have exponents in them. So now use the same one, but we're going to let x equal minus 2. So I'm going to take the minus 2. It's going to go in for every x. Remember our order of operation here. Exponents first. So minus 2, the quantity cubed. This is odd. So a negative to an odd power is minus 8. Minus 16 minus 6. So minus 16 minus 16 minus 6 is going to give me 16, 16, 6. They're all negative. I'm going to cover up the minus sign. 3 times 6 is 18, carry 1, and I get 3. Use the given sign. So my answer is negative 38. A good review for us on our signs and on our PEMDAS, our order of operations. On number 6, the question says to add these. It says add, and it has it horizontally. This is what I do. I'm totally a person who wants to line everything up. I do vertical. So I would put the 6x cubed under the x cubed, the 2x squared, and the 3x. And it said add, told us what to do. So, okay, my light went out again. So it makes no difference if I start from the right or the left. 2 minus 3 is negative x. Minus 3 plus 2 is negative x squared. 4 plus 6 is 10. Now, these signs in between the terms are mandatory. They are mandatory. They have to be there. So that is your sum. Remember, the answer to a problem is a sum. So let's look at 7b. Looking at 7b, the question says 3x squared. I can barely see here. 3x squared plus 4x plus 2. Okay, and it says to find the sum, 6x cubed minus 5x minus 7. So I had nowhere to put the 6x cubed. I don't have that there. So I can put the 5x under the 4x, and then I can put the minus 7 under the 2. So when you line them up, I cannot put that under there because it's not the same. So we're adding, and I get 6x cubed. I get 2x squared. 4 minus 5 is negative 1x. 2 minus 7 is negative 5. I think you're going to do better if you start from left and go to the right. You won't forget those minus signs there. Okay? So that was 7b. Let's see, you probably don't need to do quite as many of these as you might have, just because we've added a lot of like terms. But 8b is subtraction, and we have 14y cubed minus 6y squared plus 2y minus 5, and this is 8b, and it tells me to subtract 2y cubed minus 7y squared minus 4y plus 6. It tells me to subtract those. There's different ways of doing this. This says subtract here. So if you're going to do it this way, you're going to say 14 minus 2 is 12. You're going to say minus 6 minus a negative 7. I probably am more the type to go through. I don't change these signs. I raise them up, and then I add. 14 minus 2 is 12. Minus 6 plus 7 is 1y squared. 2 plus 4 is 6y. Minus 5 minus 6 is negative 11. I have that. The other option is you can always keep things horizontal. I am not a fan of horizontal because you end up with a big stream of numbers going across. So if you did, let's see, that was exactly what we wanted to do. But on 8a, you could keep this horizontal if you chose. Is that, remember, this says opposite. So the opposite of 5 is 5x. The opposite of minus 9 is positive. So now we have 3x minus 5x, and we have minus 8 plus 9. This gives me minus 2x, and that gives me a positive 1. Okay? This section, I didn't think I was going to have as many problems, but let's look. We are looking, this one is also, and it says subtract by columns, which is what I recommend. I use columns. I'm not a big fan of horizontal. Well, this one was easy because it was just 2 terms. But let's look at this. 16y squared plus 2y plus 1, and then it says subtract 12y cubed minus 9y squared. Be careful, you line everything up. And then it's minus 3y plus 16. So what we're going to do here, this tells me to subtract. I'm going to change my signs. I raise them up, and I'm going to change them. 4 minus 12 is negative 8y cubed. Minus 16 plus 9 is minus 7. 2 plus 3 is 5y. And 1 minus 16 is minus 15. Okay? I definitely am a fan of doing columns. Now, we don't have to stick with just adding 2. You can add 3 columns as well. So on number 10, we have 6p to the 4 minus 8p cubed plus 2p minus 1. Well, this is a lot. This actually is too much because they're not all adding. We have to subtract 1, then we have to add. So I'm not going to do that one. That one you would want to do, you would want to use horizontal for. Why? Because, excuse me, please. It's because 1 was subtracted and 1 was added. So I would totally stick with horizontal on number 10. Let's look in the problem set here. I'm looking on page 871, and let's see what we can find here. I'm not going to redo a lot of the problems like we just did. Number 8, we have minus 9y cubed, I believe, or y to the 5. Is the question says, what is the coefficient? The coefficient is minus 9, and it says of each term, then give the number of terms. Number of terms is 1. There's no plus or minus signs there. Okay? Looking at number 16, we have v minus 2v cubed minus 2v cubed plus 3/4 v squared. Okay? The question says to write the coefficients down. So my coefficient here is 1 minus 2 and 3/4. How many terms? 1, 2, 3 terms. Okay? Looking on down, let's look at number, let's see if we need to do these. I think you know how to add all those terms, 24 and problems 26 and so forth. Looking, yes, in 32, we did quite a few of those. If not, let me know that you would like to see more of those, but I think you're in good shape with that. Number 36 says, for each polynomial, simplify it. So number 36, we have y squared minus 2y minus 6y plus 5. It says to simplify, so I'm going to add these. I now have 3 terms, and it is, the question said, what is the power? The power is 2, and it has 3 terms, so that is a trinomial. So monomial, binomial, trinomial, they are exactly what the prefix says. Number 56 is add. Okay, this also is something that you've done. 4a cubed minus 4a squared minus 4. We have a plus sign. We are given parentheses. We really don't need them. 6a cubed plus 5a squared minus 8. Adding 4 plus 6 is 10. Minus 4 plus 5 is 1 minus 12. Okay, not bad. 62, though, is subtract. Let's pay attention to 62. 13y to the 5 minus y cubed minus 8y squared. Subtract. And then in parentheses, 7y to the 5 plus 5y cubed plus y squared. What I would do is I would change this to add, and I change all these upper signs, and now I add. Remember, change the sign of the subtrahend and add. 13 minus 7 is 6. Minus 1 minus 5 is negative 6. Minus 8 minus 1 is negative 9. So that is the most efficient way to do it. Change the sign of the subtrahend and add. On number 66, you know how to do. You can just add those terms. Number 74, once again, you would have to add the first 2 and then subtract the third one. So that is a little bit more. So we are on number 74. So I would write it down this way: minus 8x squared minus 3x plus 2. I'm going to add 4x squared minus 3x plus 8. I'm adding now. and this was a positive. So 4 minus 8 is negative 4. Minus 3 is negative 6 plus 10. And now it says to subtract, and we're going to subtract minus 2x squared minus x plus 7. Change the sign of the subtrahend and change all these signs inside, because change the sign and add. Minus 4 plus 2 is negative 2. 1 minus 6 is negative 5. 10 minus 7 is positive 3. And that is our final answer. Let's see if they ask us. It looks like for the geometric figures they ask us for perimeter. So perimeter tells us to add. Perimeter means to walk around the object. We discussed that already. And on number 86, we're going to have 6p squared plus p. We're going to have 2p plus 5. And then we're going to have 9p cubed plus 2p squared plus 1. So the idea there, folks, is to line everything up. So I'm going to get 9p cubed. 6 plus 2 is 8. 1 plus 2 is 3p. And 5 plus 1 is 6. And whatever units of measure they gave us for the triangle. So that completes our sections 12.1 through 12.4. And please, I will be posting the homework. Remember, we're going to be doing the odds. I never assign the hardest ones. So we're all set on this subject here. And I'm going to say goodbye, and I will go turn on my lights. But for you, I will see you next time. Take care, stay safe, don't take any chances. Have a good day.